Welcome, everybody. Glad to see everybody. We're going to talk today about creating subtitled and translated videos using some of our AWS services. And so just to kind of quickly go over the agenda, I'm first going to talk a little bit about some of the use cases, and then how we can leverage Transcribe, Translate, and Poly to put it all together into some videos. And I'll show you some code on how to do this and talk about some of the design considerations for doing this type of stuff. So first off, let's talk about some of the use cases. There's many use cases. Probably the most important one is when you're looking at your family home videos and you say, what the heck did Aunt Edna actually say at the table? You need to know. You can transcribe it now and know. But for the mundane work things, call center training and evaluation. A lot of companies are very interested in understanding, is my representative saying the right things? Do they have the right tone? Are they handling the questions from the customers correctly? And they use that as part of their scoring and training and all those types of activities. And so it's really important to be able to get the transcription of what's actually said and maybe even do sentiment analysis and that type of thing with it to be able to figure that out. A second common use case is if you think of companies like C-SPAN and so on, where they have all of this media, and they really need to be able to figure out who said what, when they said it, index it, and be able to call it up very quickly. That starts with a transcription and an index, metadata about that transcription. And so that's used by a lot of companies. It's always amazing to me when you watch this on some news show, and they can instantaneously kind of just bring something up. Another use case are things like this. It would be interesting to be able to hear what I have to say and see if I said it well and all the rest of that. And so conference talks and corporate meetings are a great venue and a great need for this. We're starting to see a trend as well for job interviews. Not everybody today necessarily goes into the particular office that they're going to work. In a lot of cases, people are all over the place, and particularly with the tight job market, they may want to or have to do remote video interviews. And so it would be great to be able to see what the person said and have multiple people be able to score that, do sentiment analysis, and all the rest of that sort of thing. So these are just some common use cases that are out there, and we're seeing lots of them. I want to show you kind of sort of what this looks like, and I'm going to start with sort of the original video here. I'll show just a few seconds of it. You'll get the gist of it. And then I'll show you what the final product looks like, and then we'll walk through how to actually build that, okay? So let's see here. Oops, sorry, wrong one.
I talked earlier about the fact that last year we launched both Poly and Lex, but there are so many other things that builders want to do with language.
So I'll stop it right there. That's Andy Jassy. Last year at reInvent, he introduced the Transcribe product, and that's part of the video that it's 2 or 3 minutes long, whatever it is, speaking just about that. So I took that video and I ran it through this process here. What I've done is using Amazon Transcribe, Translate, and Poly, I've added some subtitles, and you'll hear different language spoken tracks here. Oops. Okay, we're going to not cooperate, right? There we go. Okay, so using Amazon Transcribe, we'll first show the English subtitles at the bottom.
How about language? I talked earlier about the fact that last year we launched both Poly and Lex, but there are so many other things that builders want to do with language. And one of the things that's been interesting is that...
¿Qué tal el lenguaje? Ya sabes, hablé antes del hecho de que el año pasado lanzamos tanto Poly como Lex, pero hay tantas otras cosas que los constructores quieren hacer con el lenguaje, y una de las cosas que ha sido interesante es que hay tantos datos ahora.
Wie wäre es mit Sprache? Weißt du, ich habe vorhin über die Tatsache gesprochen, dass wir letztes Jahr sowohl Polly als auch du Lex gestartet haben, aber es gibt so viele andere Dinge, die die Baumeister mit Sprache machen wollen und eines der Dinge, die interessant.
So, pretty neat, huh? Imagine taking your own videos, translating them into both subtitled and or replacing the audio tracks with an audio track spoken in another language. This is straight vanilla, transcribe, translate, and poly. So we'll walk through this. Interestingly, I have a blog that you'll see the URL for this at the end, which I walk through everything with code, all the code in depth. You can go look at that afterward and so on. But one of my colleagues, one of my Amazon colleagues, who happens to be in Turkey, said, "Wow, this is great. Can we actually translate all of our content into Turkish?" I said, "Well, I don't know, let's try." So I simply replaced the language code that you'll see in this code, and voila, we had Turkish translations of these videos. So they're off translating a bunch of things into Turkish. And we support a lot of different languages, but we're always working on more. So if your favorite language isn't there, we can either put in a request or you can see when it'll be out. Okay, so the ingredients for rolling this are a few things. First off, there's transcribe, translate, and poly. I'll go into more depth in those in a moment. And then also, from a coding perspective, I coded everything that we're going to see in Python 2.7. I chose 2.7. You probably could do all this in later versions. That's fine. And I used Bodo 3, which is our Python API for accessing AWS services. And I also used, particularly to replace the audio track, which we'll see, I used a toolkit called MoviePy. It's an open source thing. I have the links for this out there. It's on GitHub today. It's a pretty neat, full, robust set of audio and video capabilities that are out there for you to use. Okay, oops. All right, so how do we actually get this? First off, our first piece is Transcribe. And Transcribe is a service that will take in WAV and MP3, MP4, and FLAC, so that could be audio or video. It uses some of our artificial intelligence tools to be able to come up with what the words are, so timestamps and confidence scores. I'll show you what this looks like in a minute. It's integrated with S3, so you put the input files into your bucket. It can produce the Json output either in your own bucket or in a pre-signed URL managed by Transcribe. It has channel identification. So in the case of the where you have the call center example that we used, often you'll have the customer service representative on one channel, so think of left, and the customer on the other channel on right. And so it makes it very easy to discreetly understand who said what without having a lot of things to identify. It automatically infers punctuation and capitalization. Now, the fun part about this is that depending on the speaker, if you say and a lot, then it gets a little confused sometimes. And I kind of laugh, Andy Jassy, I love him to death, but he almost never ends a sentence with a period. He always ends it with an and, because we always have more stuff to add, right? So you gotta watch out for that. We also have custom vocabulary. So you can take any word that either is misrecognized or it's jargon. A lot of we're IT people or developers, so we use a lot of acronyms. You can actually spell out the acronyms in the custom vocabulary and make sure that it understands them. Proper names sometimes aren't properly recognized, so you can put them in a custom vocabulary. I'll show you what that looks like in a moment. It can pick things up via CloudWatch and emanate events or emit events like you would expect. It also has speaker identification. I'll show an example of that. So speaker identification is, let's say, the example that I'm going to use is I have a friend of mine who's the principal of an elementary school, and he produces a podcast about what's going on in his school district. What has to happen, though, because of the Americans with Disabilities Act, is he has to actually be able to show that with subtitles for hearing impaired folks. And so in this particular episode of his podcast, he has a guest principal or whatever. And so in the text of the JSON, you'll see speaker 1, speaker 2, and so on and so forth. And so you could do certain things that you'd like to do with the subtitling to maybe have, speaker 1 show up on one side, speaker 2 show up on the other side, or do different colors, whatever you want to do. All the information's there for you to be able to do that. And right now it is supporting US English, UK English, Australian English, Spanish, and Canadian French as the source languages, but we're adding a bunch more. I'm not quite sure if we've announced any new languages here at reInvent. We may well have, because we're always adding languages. I should have mentioned so in sort of batch mode, you call it a job, and it does its thing using all these tools. We also have just released in the middle of November a streaming version of Transcribe. And so it can take an audio source or some sort of live file, either a live audio source or file, and you break it up into blobs, and those blobs are sent via the API to the Transcribe Streaming service, and then it will figure out what's said and send back a JSON blob back to you that you can then look through. And you'll get a progressively longer blob with more and more as the stream unfolds. Okay, so generally speaking, if we're looking at the batch mode, how do we actually make this work? First off, we take our audio or video content, we drop it into a bucket. And then from that, then we will write some Python code or Java code, whatever your favorite language is, and we will prepare a transcribe job. I'll show you code for that in a second. And it's going to then take that particular audio file or video file, it's going to run through it, it's going to leverage our deep learning capabilities, and it's going to do speech recognition and post-processing on that. You'll receive a JSON transcript, which has a pile of stuff in it. We'll go through some of the pieces of it. And then it's either going to return that JSON file to your specified S3 bucket, or Transcribe, if you would like, will manage that particular output for you, and what you'll get back is a pre-signed URL to where this JSON output is that you can then manipulate. Okay? So what does a transcribe job look like? This is Python, for those who aren't Python folks. Using our Boto 3 capabilities, it's pretty straightforward. You import the Boto 3 libraries, and I created this little method in there called create transcribe job, and I wanted to understand what the input language is, what the format of the audio was, where to find that particular media file, the media URI, the vocabulary we want to use, and so on and so forth. And then you simply establish the client. So in Boto, there's resources. So S3 is a resource, for example, but there's also clients. So SageMaker has a client, Transcribe has a client. So services, generally speaking, have clients. We create the client here, and then we're going to call the API, which is start transcription job, with the parameters that are passed in. It's Python syntax here, and the result is going to end up in this response. Okay, so what does a transcribe output look like? I've shortcutted a bunch of this stuff because they're pretty long, and I'll show this to you in more detail in just a moment. But you'll have the transcription job name, whatever that is, your account, whether it's completed, what the language was that it detected for the inbound processing, what the Hertz rating was for the sample rate, the media format, and then you'll get the URL for that particular thing. Depending on which way you do it, you'll actually get either the URI or you'll actually get the transcript right in there. Okay, so if you put it to your own bucket, you'll get this URI instead. So if you think of this, you could take this and index this. You could stick it into DynamoDB or Elasticsearch or whatever your favorite database is to understand when a transcription took place and where do I find the transcript for that. Okay, looking a little bit more at the JSON output of the JSON that was referred to there, it's going to have a few things. It's going to talk about the job name, and then it has a number of sections. One of the key sections here is the items section. And so what you're going to get is you're going to get word by word what was actually identified. So you can see that for the first word here, and if you think what Andy Jassy said, he said, well, what about language? Or how about language, I think is what he said actually. So the first word is well, it has 100% confidence that it correctly recognized the word well. Here is the start time. It started at 8.282 seconds, whatever. There's the end time of the word. And the fact that it's a pronunciation says that it's actually a word. I put in another thing here, which is punctuation. So it infers punctuation, but punctuation doesn't have a time code per se, because it's usually attached to the previous word or whatever, right? So in this case, you'll see that it has the content that'll show you what the punctuation is, and it'll tell you that it's punctuation. So why is that important? Because when we're going to walk through this output, and we're trying to build out what the subtitles are going to say, we want to actually take the word and the punctuation and put them in the right order within the phrases. Okay. So how do we actually get subtitles out of that? So what we need to do is we take that transcript and we need to run it through some code, Python code or whatever, could be Java code, whatever. And a commonly used format for subtitles is called Subrip files. So they're typically either SRT files or they could be VTT files, whether they're web VTT or SRT. Okay? So what is a Subrip file? It's a common format used by Facebook, YouTube, a bunch of these different media companies. And what it has effectively, and I'll show you some real examples and compare them in a moment, is it has a sequence number followed by a new line. It has the start and end time of the actual text that you want to show up on the subtitle. And the format's a little bit different, whether it's SRT or web VTT. I'll compare them in a second. As well as the text that you want to display. Okay, and so this is what an SRT looks like. You'll see the time encoding here. It starts out at 2.6 seconds, and he says, well, how about language? You know, I talked earlier about the fact. So you can see exactly when the first words started and when the last word ended. Okay, but remember what we get from JSON is we get the start and end time of each word. So our job here, we'll see in a second, is to actually figure out where each word starts and where the first word starts and where the last word ends, so that we can correctly encode this particular VTT file so the video and the text lines up. Okay? In web VTT, it starts with the web VTT tag, I guess you'd call it. And it's a very similar format, but a couple of things to notice. One is it uses decimal places rather than commas for the hundredths of a second and so on. And it also provides the ability to put some formatting information in there. So there's a whole host of things. I encourage you to go out and look at Subrip and WebVTT. I put the links up there for you. Go look at them. There's all kinds of stuff that you can do with this. You can change font size, you can change color, the position on the screen, you can turn it on its side, you can do all kinds of stuff with it. And it's simply tags like that. You know, I put in quotes, air quotes, kind of their HTML-like tags without having all of the HTML angle bracket stuff. But same text and so on and so forth. Why do you care about that? Because different readers prefer WebVTT over SRT. Some prefer SRT. So you got to know what you want to deploy it to. All right, so the process here in more depth is, and again, you can go to, this is the blog that I wrote, and I think the session notes here will be available online, so if you don't catch the URL, you can always get it afterward. But basically, you need to loop through the JSON output word by word. And then what you need to decide is, how am I going to create phrases that are going to fit on the screen? Because I can't put 10 minutes worth of video on one screen. I guess you could, but it really wouldn't be that awesome, right? So my visual guess was about 10 words or so. And of course, that's going to depend on how long the words are, but 10 words or so in a loop here. And for each of those words, we need to create the correct time encoding. And part of the time encoding conversation is a translation, if you will, between what the transcribe output for time encoding looks like and what SRT/VTT expect for time encoding. So you need to fix that up. In the blog, there's a little function that converts it for you. And then for each phrase that's captured, you need to put the start time of the first word and capture the end time of the last word, and that has to be put together into that phrase. If it's SRT, we're simply going to write the sequence number, the time encoding, and the phrase. If it's WebVTT, we're going to put the sequence number, time code, the format, and the phrase. Okay, make sense? You've seen what the files look like. So you go through and you figure that out for each of the pieces here. If you're doing VTT, you can actually take that output and directly embed that into pages, web pages, HTML5. HTML5 has a video tag, and you can see some of this up here, setting up some of the bounding box here for that, but some other attributes, controls, and autoplay and all that stuff are available. I'd suggest you look at the HTML5 docs. There's a bunch of things you can do with it. But then we're putting in here the source, so what is the audio or video, whatever is going to show, and what type it is. But then for every language that you want to show a subtitle for, you're going to put a line in underneath that says track, and what the source is. So the source is the VTT file that we produce out of the process, and what you want to have labeled in the right-hand side when you have the little closed caption thing, you can pick up. I'll demonstrate that in just a minute. But whatever you put in there is what's going to show up for the user to select the appropriate language. So let me flip this over here. All right, hopefully that's big enough everybody can see it. Is that good for everybody? Yeah? Okay. So I'm starting here with a custom vocabulary. And the use case here, again, is my friend who's the principal of an elementary school. The name of his podcast is the Scoop Podcast. And he is in Hopkinton, New Hampshire. When I first ran this through, it didn't get the word Hopkinton, it got hopping in, which isn't exactly what we want to see. We want to see the actual word Hopkinton. Oh, and just in case your eyes are not deceiving you, I'm running this in a Mac, but it's one of our workspaces, which is Windows running in a Mac, just to make everybody happy or everybody mad. I'm not sure which, right? But I did this because, I wanted to demonstrate that you can use our Workspaces product. It's just fine. You can use it for development or whatever. But also for those who have locked down Macs, my company laptop is more or less locked down, and Apple's base structure, it wasn't easy to update pip and so on and so forth correctly to get all the right versions of things. Whereas by putting this in a workspace, I had control to be able to put all the versions that I needed to make this happen. If you've got your Apple fixed, all this will work on your Apple too, but that's why I have this running in a workspace. In any event, so this is the custom vocabulary that I used for that particular thing. I want to show you, so again, here's the HTML file that's going to be the source for what we're going to see in just a second. I think I told you about a colleague of mine asked about Turkish. So I actually used this particular podcast as an example to try to translate it into Turkish. And so we'll see Turkish subtitles here. So the VTT file for English looks just like this. He's going to say, well, hello and welcome to the Scoop Podcast. I'm channeling my buddy here, right? But you'll hear him in a second. So it goes through, and the whole audio is there. If I look at this in Spanish, again, here it is in Spanish, and here's what it produced for Turkish. I assume that's good Turkish. I'm sorry I don't read or speak Turkish, but I hope that's correct. And before I jump in to show the video playing, I just wanted to show you a more full version of the output JSON, because I only took a little set of snippets. So you're going to have, as I said, the account ID, the job name, all of the items word for word. And so if I scroll through this, you can see it goes on word for word for a whole long time because it's covering the entire podcast. And then when we get down, we're still in that. All right, then we get into speakers. So there's two speakers. There's Bill Carrozza and Amy Doyle. And it recognizes for each and every word the start and end time for that particular word or the phrase, who said it, and so on and so forth. So you could go through and attribute who said what at any particular time. And then it'll also show you, if I scroll down to the very end here, I didn't pretty print this, sorry, but there's the transcript that has the whole text of the whole transcript laid out for you as a JSON item. Okay, so then if we look at this within here, so let's see, I'm going to just go before that, and we evidently have English subtitles. So what I was saying before is, see how we have here you can turn subtitles on and off. You can pick whichever language that you've actually provided a VTT file for, and I'll switch them dynamically back and forth between them here. So if I play this here.
Welcome to the Scoop podcast for the elementary schools in Hopkinton, New Hampshire.
Okay,
I'm Bill Carrozza, principal of Harold Martin School
it
and
over
Maple
to
Street
Spanish.
Schools. Coming up today on our Inside the School segment, we'll have an interview with Assistant Principal Amy Doyle all about this year's significant initiative on responsive classrooms. I'll run down the major events of the next month or so in our schools and talk.
Okay, so you get the idea. You could simply produce the VTT files and put your content out, your original content, just with subtitles, and produce it in whatever language we support that you want to produce. Okay. So how do we translate? So first off, let's talk about translate. Translate itself is a neural machine translator. And we continually are building up that neural network and enhancing its capability to recognize words and translate them into the appropriate phrase and idiom and so on in the target language. It considers the full context of what you give it. So have we ever tried to do translations on one of our mobile apps, and you do it word for word, and it gives you a word, and it might be a reasonable translation, but it's not the right translation for the context? Anybody ever done that? I know I certainly have. This is trying to consider the entire context when it's doing the translation to get it as grammatically and contextually and idiomatically correct as possible. Right now we support 21 languages with more to come. And we do this in real time, the translation in real time, in an average of less than 500 milliseconds on an SDK call. It does auto language identification, so it understands exactly what languages we're doing. It can do it with SSL and encryption if that's your requirement. It also has custom vocabulary so that you can add in your own set of acronyms and jargon and all that stuff for the particular language, because they may be different in different languages. And the interesting thing is you're just paying a cost per million characters. So you can translate all day long if you want, and it's $15 per million characters currently. Amazon Polly, which you heard a little bit of that speaking Spanish and German earlier, is a lifelike speech tool that's based on our deep learning capabilities. We currently support 57 voices in 27 languages. And you can take those, the output of this, and store it and redistribute the speech. So once you've actually done the translation and you have it spoken through Polly, what you can do is produce an MP3 file out of that. And once you have that MP3 file, it's yours. You can have unlimited replays of that particular MP3 file for whatever you need it to do. It does real-time streaming as MP3 or OGG files. You can customize the speech output, and so those are things like being able to control the speed of the speak back. You can deal with some of the voice inflections and so on. I didn't say earlier, it supports SSML, which is a voice markup. So if you want to have a Polly voice reading back something, you can inject breathe here and all those kind of things, and it'll actually make it sound even more lifelike because we expect as humans to hear breath as people are talking. Okay, and again, this is you're paying per character converted here. So there are some design considerations when you're actually trying to put translated and translated audio or translated subtitles in to your video. So first off, do you need it to be batch or real time? If you have the call center scenario, for example, you might want to do some of that real time and you might want to do some of that batch. If you're looking at everything that happened today and you want to go back and be able to get transcripts out of it, batch is probably perfectly adequate. On the other hand, if you want to be able to tell in real time the sentiment of the customers, is there some, if you're a financial services firm, is there some market event that is happening and you want to be able to tell if people are really upset or not? Maybe you want to actually do some of this more in real time and be able to tell sentiment analysis. Because maybe you want to change what the customer service person is saying. So both are legit, but you have to decide because it's a different set of code to actually figure that out. Does it need translation or simply subtitles? So, just to keep in mind, so you're paying every time you make an invocation. So if you don't need to have the translation, have it spoken, then don't make the call. If all you really need are just subtitles, you just need to make a transcribe call and then however many languages you want to call for translate, that's all you need to call. If you don't need to call Polly if you don't need it. So what is it that you actually need? And if you're just looking at pure translation, you don't need transcribe at all, but you need some text input because it translates text. Another consideration is we don't, in English, say things the same way that they say things in German, for example. And I have relatives in Germany. We kind of kid back and forth about the language structure. In German, it tends to be, and I'm completely generalizing here, so don't shoot me, but just as an example, they tend to put a lot more of the nouns and stuff up front in a longer sentence and the verbs in the back. And so if you translate this without actually looking at the whole sentence, then you're going to get some weird translation because it's not going to understand what the verbs were for the sentence. We have a particular rhythm of it in English, and other languages, I understand in Japanese, for example, men and women don't actually speak the same way. They have kind of a different set of language structures and so on. So all of that has to be considered when you're putting this together. What are the idioms? What are the colloquialisms? If you can say that, I can't say it. What's the scope of translation? Should I do it word by word? Should I do it phrase by phrase? Should I do it sentence by sentence? Should I do the entire thing at one time? How should you do that? That's going to change the number of calls you make, but a specific limitation in the Translate API is that you can't send in more than 2,999 characters at a time. So if you're going to do the whole thing, then you got to break up the input into blocks of that size, and then you can get the output out and deal with that. Okay, and then finally, when I grew up many years ago, on Saturday mornings I would watch Kung Fu theater. Or black belt theater, and then watch cartoons, right? So when I would watch those martial arts movies, what I always used to be entertained by is that the audio of their voice never lined up with their mouth, right? And you'd hear, thwack, right? It was always kind of funny to see it. But that's a real problem that you have to face when you're actually doing this translation. There's not going to be, in many cases, the same number of words or the same length of time when you're getting the translated output out. And you have to find out how to marry that up with the audio or video so that it's reasonably close to where it's supposed to be. You don't want the video to end and still have the person talking, right? So somehow or other you have to figure out this. And so these are all sort of some high-level design considerations on how you want to structure this. So how do we do this? Well, first off, we take our JSON transcript from Transcribe, and we're going to run that through Translate. And Translate is going to produce the target language. And what I have done is I've taken the entire block of text because I wanted to get the best context I could, and broken that up into the 2999 character blocks, and I translate those as a block in and of itself. And then I run that through Poly. Now, the question is, though, how do I actually align this in Poly? Because if I sent the whole thing through Poly, then I'd get one long MP3 file that would not necessarily line up, right? So what I have to actually do is I need to, or what I did at any rate, is I actually take and break the translated output up into phrases, and then I actually have Poly speak each phrase. I capture a temporary MP3 for each one, and then inject that into the video. And so we can see that in the code here. So how do we call Poly? Well, Poly and Translate both have clients, just like I was mentioning before. Poly actually has a voice ID. So if you go in the console, you look, there's 57 voices with, I forget the number, 21, I forget the exact number. It's earlier in the presentation. But the point is that there's usually male and female spoken voices in each of the languages. In some cases, there's multiples. In German, for example, there's Vicky and Hans and I forget what the other lady's name is. But there are 3 different voices. You've got to give it a voice ID. Then you take the text and you're going to run it through. So there, you see the 2999 there. So I'm taking the first block of 2999 and I'm sending it through to synthesize speech. And I want it to come back in MP3 form. And when I did this, it only supported 22K as the sample rate. You know, a lot of audio today is in 44/100 if it's high quality, CD quality. And I think that they have either changed this or it's soon to be changing. But in any event, you take the text, you put it in, you're going to get back an MP3 file as a stream. So you need to then take that audio stream and write it to a file. And so here's some code to do that. I have the full code in the blog if you want to go and take a look at this. But it's just taking the stream, pulling the stream out, writing it out as a stream to the file, close the file, and we now have an MP3 of that phrase spoken in whatever language. Okay, so how do we put this all together? So we're going to take our original audio content, we're going to take the SRT file or VTT file, and we're going to take any spoken things like Poly, and we're going to run them through MoviePy. Now, MoviePy, to explain a little bit more about it, as I said, it's a full-featured set of capabilities out there on GitHub. I'm sure there are many libraries. I just happened to choose this one. So what you can do with it is it will allow you to either composite things, so I can put things on top of one another, or you can actually sequence them to say, I want this to show up, and then this to show up, and this to show up. And then it'll create a brand new video output on that and or audio. Also what I've done is I've taken the original audio of Andy Jassy speaking, and I basically shut the audio volume down to 0, and then I brought the Poly audio in and raised that up to 100%. So I overlaid the audio so that you could hear it spoken in multiple languages. Okay? Does that make sense to everybody? Okay. So I'm going to leave this up here while we go through Q&A, but here's some of the key things, key URLs that you need to know. So the first one is the blog, and I've laid out all of the code. It's all there to do the entire process. Step by step how to set up the Windows environment to do this, whether you use workspaces or a plain old Windows desktop. And I'll tell you the hardest part of the whole thing is getting the environment exactly correct, because how many have ever experienced, I pick open source version whatever of this tool and open source version of that tool, and they don't actually really talk. They sort of talk, but not really talk. So that's the life of today, right? You just need to pay a little bit of attention when you're setting the environment up. If you can run, and I show this in the blog itself. Actually, why don't I bring up the blog? Yeah, that's okay. All right, I'm just going to get out of presentation mode here. Oops. All right. Oh, is this showing up on the other monitor? Yeah, that's probably what's happening. Yep. All right. There we go. All right. So if we kind of scroll down through this, have a little bit of a process there, talk about what the tools are, walk through step by step on how you set the environment up, what Python version, what you should see if you've correctly installed things as you're going through it, how to install the CLI, how to test it, make sure that it's working correctly, the other packages that are required within Python. And then there's a little program that MoviePy itself provides to test that MoviePy is correctly installed. What you need to do on this is you need to replace unless you happen to have a video called myholidays.mp4, you're going to need to replace that with your own particular audio or video content. And then down at the bottom, when you want to write the video clip out there, you're going to want to replace that with whatever you want it to be called, which is on the line that's not available there. So in this case, they chose it as a WebM output file, but it could be MP4. It can be a whole series of particular formats. Okay? So then, as I was suggesting earlier, walk through all of the code line by line with comments in here so you can take a look at this. I'll tell you what I didn't do in here. If you're expecting to have every error condition checked, I did not do that. And I didn't do it on purpose because it would have, we all know we've written defensive code. You can make this thing like huge. And for purposes of having a conversation like this, I err on the side of clarity rather than putting all defensive production class coding in place. I just want to forewarn you of that. It's not that I'm a bad coder, really. I just didn't do it on purpose. Okay? So if you walk through, the whole thing is here, how to put it together, how to create the subtitle files, more in-depth about the design issues, and so on. Okay? So let me just go back to the end here, put the thing back up again for you. All right, so questions? Yes, sir. So the question was, and I'll paraphrase this, so tell me if I'm misparaphrasing this, but what's the order that you decide when to do the custom vocabulary files? Do you run it through first and then say, oh, this is wrong, this is wrong, this is wrong, create the custom vocabulary, or do you create it first? And I think my perspective is it depends on what you're trying to do. If you know that the video itself is going to be full of jargon, full of proper names, full of all that stuff, I would create the custom vocabulary first. If for no other reason, then, we're very, at Amazon, we want you to only use what you need to use. So every time you run one of these transcribe jobs, it's something that you pay for. So if you already know it's full of acronyms and jargon, create the vocabulary first and then run it through, because you'll get a much cleaner first run hit on it. It may be that you don't know, particularly if you're putting this in an automated process, and you simply just don't know what the content is going to be, then I'm not sure that just doing a custom vocabulary itself is going to help you to start. You're going to have to then look at the output and see what's kind of right and wrong about it. Does it make sense? Okay. Yes, sir? Oops. Just so, because I guess this is being recorded, if you could actually use one of the microphones, then they'd be able to hear it.
So when you picked the number 10, what if you had picked for your video to show the words, would it truncate it or would it wrap it if you picked the wrong number? So like if you picked the number 12.
Yeah, it'll wrap.
It'll wrap it? Okay.
Yep.
How about different accents? Do you need a custom vocabulary for that?
So can you elaborate further?
Like English accent is spoken in, English is spoken in different accents, right?
Correct, yeah.
Like Indian accent is different, American accent is different, British accent is different. Right?
Yeah.
How do you transcribe for that?
Well, first off, it's part of the models, the deep learning models. It is able to recognize those inflections, the different words, the different idioms, whether you're speaking British English or Australian English or whatever. So that's part of the underlying model in and of itself. And kind of the fun part, and I can demonstrate it if you want to see it, is that on the flip side, if you have it read through Poly, Poly's voices have been modeled after native speakers in whatever the language is. And so the interesting part about that, the fun part is that you can take, say, an English sentence and have it read by, pick a language, Cantonese, and it will have a Cantonese accent reading English, or an Indian accent reading English, or whatever, because the voice modeling is trying to imitate how the native speaker would speak whatever is sent to it. So it's pretty interesting. Yes?
Your podcast example had,
Yep.
I think, something like inside the schools or whatever in quotes, because it was the
Yes.
title of what they were doing.
Yeah.
Was that something added manually, or did it figure that out?
So I put that as a vocabulary
Oh, I didn't see it.
item.
Okay. Included in
Because-
the quotes.
Yeah, so when it first translated, it did inside the schools just as like a regular part of the sentence. Not capitalized or anything, but I prefer to actually have proper names capitalized properly. And so I just added it as a custom vocabulary word so that it would correctly recognize that phrase.
Oh, thank you.
Yes, sir.
Great talk, by the way.
Thank you.
So let's say I have a large catalog of podcasts of various speakers.
Yeah.
Some can be transcribed well, some not. Is there a formula that I could use to take the confidence scores of all the words and turn it into the confidence score of the entire podcast to decide whether to even bother show captions for a particular podcast?
Well, that's an interesting question. From the perspective of, so you're going to have the confidence score for every word.
Yeah.
So it seems to me algorithmically you could look to say if just doing something simple, if the average of the words is less than 75%, maybe you don't publish it. If it's greater than that, maybe you do. We can chat about it after, but I think there's plenty of algorithmic things that you could do because you have all the metadata about each word to do that kind of thing. One other thing that I would comment on is that the quality of the audio is very important. So obviously, the higher the hertz rating, the better quality of the audio in theory. But if you have if the person's standing at the street corner, and there's buses going by and all this sort of stuff, and you're trying to pick things up, a lot of transient noises, it may or may not pick up those things correctly. And, we human beings have a hard time understanding that stuff when there's a lot of background noise too. So I think you got to look at the overall quality of the audio. One other sort of audio engineering kind of twist to it is that if it's just a spoken voice, people tend to speak in a particular frequency range. Most folks hear well between 800 hertz and 3,000 hertz, with sort of the curve being around 1,000 to 2,000 at the top of the curve. If there's a lot of boomy, muffly, bassy stuff, you might be able to actually process it through, pick your tool, Audacity, whatever it happens to be, and re-EQ the thing so that the voice frequencies are going to come out better, and it will probably recognize things better. So it's hard to give you a specific formula because it's going to depend on what the content actually is.
Gotcha. Thanks.
Yes, sir.
Hi. You touched on it very briefly in the chat, but I'm interested in some of the live streaming elements and being able to do live transcription and live translations, and
Yep.
just wondering how that would sort of work with the latency and things like that obviously these services may or may not have with being able to grab a live stream, do all of the transcription and then throw the subtitles out.
Yeah, so I touched on it briefly. And I did a chalk talk on this subject yesterday, and I
missed it,
actually
unfortunately.
covered more of the live streaming in that particular talk. So in the middle of November, we came out with Transcribe Streaming. So to me, the sort of critical path step is getting the transcription of what's said. Because once you've done that, you can do comprehend, you can do poly, you can do translate, and so on and so forth. The translate itself is almost always less than less than 500 milliseconds. And so even if you think of closed captioning today on a regular TV broadcast where it's live broadcast, it's usually behind by a half a second, right? Because it's doing some processing. So that's certainly possible to do today with our transcription, our live stream transcription. You hook the audio source in, you're sending in the chunks of stream, have it transcribed, and then go through the exact same process if you wanted to, that from the translate onward, and it'll give you the translation and the poly audio, which could then be re-injected into the stream. So it would be behind a little bit, but I don't know how much latency you would require. But I think even in today's broadcast quality, it's behind a little bit because they're having to figure all that stuff out. So I think you could probably get pretty close today with things just as they are with these tools. Does that make sense?
Yeah, it's mainly around getting the important part you're talking about, Polly, with the sync of the actual people talking with the subtitles. I noticed the keynote this morning was a little bit kind of behind, and I thought they might be using this sort of tech to generate the subtitles there.
It well could be. I didn't actually, hate to say it, I didn't see the keynote this morning, so that's okay. But yeah, I'm sure that they were using the same technology.
Great, thanks.
Yep. I'm sorry, I didn't see you guys over there.
Oh, it's fine. Could you use Media Convert instead of MoviePy, or do you require the granularity that MoviePy provides to stitch all the assets together?
Yeah, so interestingly, when I started this process, some of the elemental tools weren't available at the time. And I did this more as so my role is I'm a solutions architect, and so I work with partners, I work with customers. And I did this more of as an educational thing to actually help people to understand how to use our services. And they said, this is great, and so I interacted with the Elemental team. They produce production quality tools that do some of the stuff specifically. And so I'm quite sure that they either have or will have at some point this capability built into a number of the Elemental tools. Because everybody needs this, right? And we are always focusing on what our customers need. So you can perhaps do this today with this. You don't need to use MoviePy. You can use whatever toolkits that you want to use. I happen to choose that because it was something that I could wholly contain. It was open source and all that stuff, and use it as a teaching tool, if you will. But you can use anything you want, anything that's available to you that works for you and your situation to convert the things over.
It seemed like you did some of the alignment stuff in MoviePy, though. Is that correct?
I did the mathematical stuff within Python code. I simply used MoviePy to composite the audio on top of the video.
Okay. Thank you.
Yep.
Just a quick question. How fast is the transcribing? Say, to transcribe a 1 hour long video, do you need 1 hour to do the transcribing, or 5 minutes, 1 minute?
So I think it depends on a number of things. So you're starting up a job, and the jobs start if you have let me start here. I have not transcribed an hour-long video, so I don't know how long clock time it would take to do that. There's a minimum startup time to start up the job, which is usually a few minutes. if you're doing it job-based. It's different than the streaming base, okay? So obviously, you're going to pay a fixed cost, if you will, in terms of time to start the thing up, and then it's just a matter of processing things for however much content you have, which takes into account the bit rate and a whole bunch of things as it's walking through things. So I don't know how long it specifically would take for an hour-long video. We could try to benchmark it, or you could benchmark it, but it's going to take at least a few minutes to do any one of them. Okay, so that's why that's one of the reasons why we created the streaming model, because if you need to do, whoever asked the question about the sort of the live streaming, a few minutes to start up is not going to work, right? So, but if you're doing a batch set of transcriptions for 1,000 videos, that will be just fine, right? So you got to know what it is that you want to do with it, and how much time it's going to take.
Because I want to transcribe a library of video, thousands. I want to know, is it just one-to-one time-wise? Or?
As far as I understand, it is not one-to-one. It's actually pretty fast, because you're taking digital content and then running it through a deep learning algorithm, a machine learning algorithm. So it's really an algorithmic speed, but there's setup time that has to be incurred to set the environment up to pull in and process the audio in the first place. Okay? So it's as far as I understand it, it is not one-to-one.
Okay, great.
Great. Okay, well, are there questions? Yes? Yep.
Real fast. So the code that you provide, it converts the output of Transcribe, the JSON, into like web BTT?
Yeah, it does SRT specifically.
SRT, okay.
And the reason I did SRT is because that's what MoviePie understands.
Cool, thanks.
Okay, but the other example that I did, it's almost the same exact code. I just tweaked the code to produce, the WebTT header, and then I added in a little bit to add the formatting piece. Okay. But the rest of the code is pretty much the same.
Cool.
Okay?
Thank you.
And that's all available on the blog.
Nice. Okay.
Other questions? Well, thank you very much. I appreciate your time and attention. Please download the blog. Please leave any comments. Let me know if you have any issues. I'll be happy to help you through it as best I can. And please make sure to fill out the survey. We'd love to hear your feedback on the session. Okay? Thank you very much.